Hello, Royals. Let's tackle another example from our last lesson on the intersection of three planes. Now, you really should take a look at the printed lesson and the supplementary orientation page because there are a lot of possibilities here. There's parallelism, there's fans, there's lines of intersections, there's points of intersection. You can kind of trust the system and see what the system tells you, but like with other intersection lessons, a bit of an analysis either at the start or when you get nervous couldn't hurt. And there's a couple of homework questions where they really just want the analysis, not the intersection. So let's try this one out. Let's find the intersection if it exists. We're given three planes. First thing I should probably do, I kind of scan through and I notice that there is no parallel normals, which means I can't have any parallel or coincident planes. That removes what, like more than half of the possible orientations here. If I had parallel normals, I might stop and not solve the system and just do an analysis to predict what's going on here. It could make the question a lot easier. In this case, I think I'm just going to jump into the system and see what happens. Now, try it with me. I'm going to eliminate one variable. Y is kind of begging to be eliminated here. If you wanted to try eliminating Z, it's going to look about the same. If you eliminate X, it'll look a little different. But again, try it out as extra practice here. So we have plane 1, plane 2, plane 3. Let's just go ahead and label these equations. I have decided that I am going to eliminate, I said Y. I'm going to change my mind. Let's eliminate Z. Right. And yeah, the reason why I made this choice is I already have two coefficients that are opposites of each other. So let's take an elimination of Z by doing, how about equation 1 plus equation 3? That's going to give me 4x plus, 0y, this again, plus 0z, I wanted that to eliminate, equals negative 4. Right, now this statement on its own just says 4x equals negative 4, or x equals negative 1. Now, I should be a little bit nervous right now because this doesn't normally happen. Usually I have to perform two eliminations on Z to get two different equations on X and Y, and then do another elimination to either find a contradiction or a truism or a value. So yeah, I might get a little bit nervous right here, but I know that I'm going to trust the system that if equation 1 and equation 3 are going to be true at the same time, X has to equal negative 1. This is a true statement, I think. So I'm going to label it statement number 4. Okay. What I could do now is, trusting this value, simplify my system by getting rid of one of the unknowns now. If I could replace X with negative 1 in every single one of these equations, and then I should have maximum 3 equations on 2 unknowns. If you get where statement 4 comes from, you know that that's not really going to happen. But let's see what happens if I try doing that. Okay, I used equation 1 and equation 3. So let's substitute 4 into equation 1. That's going to tell me that negative 1 minus y plus z is going to equal negative 2. I'm going to tidy this up. I don't like the leading negative. I'm going to add y to both sides, subtract z from both sides, and then add 2 to both sides. So that'll get me the equation y minus z has to equal 1. That's statement number 5. So here's where I'm going to do something a little silly. I'm going to substitute statement 4 into equation 3. And this is sort of silly because statement 4 came from the combination of 1 and 3. So when I do this, it should agree with statement 5. Let's watch. If x is negative 1, this is going to be negative 3 plus y minus z is equal to negative 2. I add I add 3 to both sides, and yeah, I get y minus z equals 1. This is pretty much the line of intersection of these two planes, where x is always negative 1, and then this statement has to be true. So a bit of waste of time. A little embarrassing, honestly. I need to use all equations in the system, though, and I haven't used equation 2 yet, so why don't we put statement 4 into equation 2. That's going to tell me that negative 2 minus y minus 2z is going to equal negative 9. I, again, add y to both sides. This time add 2z's to both sides. and then add 9 to both sides, and I get y plus 2z has to equal 7. So one of the ways of thinking about this, I kind of mentioned it back here, as this being the line of intersection of plane 1 and plane 3. You could think of this as being another line of intersection, and these two lines aren't coincident. Where those two lines intersect is going to be our point of intersection. I might want to convince myself a little bit later that there actually is a point of intersection, but I'm on track now. I've eliminated one variable and I got a value of x. I now have a linear system of two equations on two unknowns that agree with all of these equations because it just follows the truth of my elimination. And I realize now that I'm set to, I don't know, let's say eliminate y. Let's eliminate y by doing equation 6 minus equation 5. Y minus y will be 0. 2z minus negative 1z will be 3z. And 7 minus 1 will be 6. And hey, look at that. That just tells me a constant value for z. I suppose it's possible that like y could be parametric, and I'm still talking about like a line of intersection where x is always negative 1 and z is always 2, and then y can be anything. But I don't think that's going to be the case, because if I take statement 4 and statement 7 and say 4 and 7 into, let's see here. Actually, I don't need 4, do I? I just need to take, I know what x is. We could substitute it into 1 or 2 or 3 and rediscover what x is, but if we take statement 7 and substitute it into statement 5, we get that y minus 2 has to equal 1, which means that y has to equal 3. Okay. I would understand if you'd be a little bit nervous because maybe it felt like we didn't do as much elimination as the example in class. So your options here are you could test this solution to see if it satisfies all equations. Let's try it out, see how we do by hand. Negative 1 minus 3, that's negative 4, plus 2 would be negative 2. And negative 2 minus 3, that's negative 3. Whoops, where did I go? Negative 2 minus 3, that's negative 5, minus 4, that's negative 9, and negative 3 plus 3, that's 0, minus 2 is negative 2. So this ordered triplet satisfies all of the equations in here. Okay, it would take a little bit of time, but it might have soothed my concerns on this very first step if I had done a normal analysis. If I had done my triple scalar product, and I'm going to choose to do what I think is the easiest cross, 1, negative 1, 1, crossed with 2, negative 1, negative 2, and then leave the bigger number 3 for the dot, 3, 1, negative 1. Right. Let's see. 1, negative 1, 1, 1, negative 1, 1, and 2, negative 1, negative 2, 2, negative 1, negative 2, squiggle, squiggle. This gets me 2 plus 1, that's 3. 2 plus 2, that's 4. And negative 1 plus 2, that's 1. I dot that with 3, 1, negative 1, and I get 9 plus 4 minus 1, which is 12, which is not 0. And this means that I have non-coplanar normals. Notice doing this check first would also, if I know that my normals are non-coplanar, that means that they can't be parallel either. Okay, parallel normals are definitely coplanar normals. Okay, 3 of them, I suppose. We have 3 non-coplanar normals, and the only way that can happen is there's a point of intersection. So my question to you is this worth it? Would you feel much more comfortable with this conclusion saying, oh, I just happened to quickly find the x value of the point of intersection, and I knew there was a point of intersection because I had done my analysis? I think it might be worth it. We've been practicing crossing for a while now. So the point of intersection of these 3 planes is negative 1, comma, 3, comma, 2. There's always the danger with a test. What are you going to do if you do the test wrong? Panic and then write a sentence saying, well, my test predicts that there should be a point of intersection, but I didn't find one, or my test predicts that there shouldn't be a point of intersection, but it looks like I kind of found one. Okay. Think about analyzing your normals first. I think it's worth it given all of the possibilities. I don't think a sketch, an accurate sketch, is useful, but anything you can do to make the solving of the system easier is really going to be beneficial when we have 3 equations on 3 unknowns. Okay. Make sure you practice plenty of intersections of planes. They're long questions, but you'll get better at working quickly and accurately with practice. So I think you should try it out.